All right. So the miscellaneous part, maybe I go back to the beginning of that chapter. This is all this chapter is about. Translation, blah, 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 then the graph of reciprocal function. Remember, the reciprocal function we did before is 1 over x, right? What if you have more than 1 over x? What if my original function is ax squared plus bx plus c? What does the reciprocal look like? That would be our next target, okay? So we should be able to do that by tomorrow. But for today, I thought we should practice this miscellaneous. By miscellaneous transformation, it means it's not like, oh, all the questions are translation, or all the questions are stretching. Another name for stretching is? Dilation. Or all the questions are strictly based on this. The 16 ABC that I gave you yesterday were specifically for each one, right? But here, now you are going to have combination. Because your exam is not going to say, this is for translation. Question A is translation. You understand that? Yeah. It's going to be a mix. So let's practice the mixture. And that is what this section is all about. And that's what I want us to look at today. So again, this is the concept map that we are going to be using. So there are 3 main ones. Like we said yesterday, translation. So if you are translating, this is the horizontal translation, A unit to the right. Is that not? Because of that minus. And if you have plus, it is A unit to the left. Okay? And if you have just a variable or just a constant added to the entire function, you are talking about the vertical translation. Okay? And this is example. So you can see what happens. Please take note of this concept map. That was why I printed it for you, because in the exercise you are doing today, you really want to be careful how you move function upward or sideways. This looks like it's not really different from the entire function, isn't it? But if you look at this, you see this part is here. This part is what moves here. So don't be deceived. There should be a bigger space here than over here, something like that. Okay, just be, bring in your artistic skill as well. Then the other translation we did was the stretching. We have the horizontal stretching and vertical stretching. During the vertical stretching, your x-axis is the invariant, isn't it? It doesn't change. And during the horizontal, the y-axis is the invariant. So don't forget all we discussed yesterday. You have the paper with you. And the last but not the least is when you have reflection. So even though yesterday we only talked about 2 reflections, but you have actually done 1 reflection in the past, right? Yes. The relationship between a function and its inverse is reflection about the line y is equal to x, isn't it? We've talked about that in the past. So that's why the mind map, the concept map also includes that, okay? And this was these were the 2 we did yesterday. So like I said, try to check both with a quadratic function, the easiest way. Once you put a negative, you change it from concave up to concave down, as the case may be. So then you know, oh, if I put negative, it's just a reflection along the x-axis. Definitely, f of minus x is a reflection along the y-axis. Do you understand? That's how I will remember if I'm a student learning for the first time. I try to remember the easiest one, automatically the other one is the second case. Okay? So that is that about, and you can see some examples. The original function in maybe black, I don't know. Yeah, in black because of this A. And the reflection is on red. So you can see it's a mirror. And look at this one also, the original one in black, the reflection in red. Okay? So with this mind map, I keep calling it mind map. With this concept map, let's play this example. So then I think there are about 2 examples I would like to play for you. Then all these questions, I put it together as a worksheet. Not all of them, I think some of them that I find interesting. And we will look at this also, and that is the end. You are welcome to try more questions on your own from your textbook. In the HL book, it will be in book 1. You can find it on page 440 of book 1. While in the SL book, I think you can find it on page 112 of the book 2. So just look out for book 2, transformation of functions, It can be found on page 112. I think I checked that this morning just to confirm. So the topics, the questions are all the same. All right? So let's go to the first example. Okay, that looks weird. What happened to your speaker?
Function f of x. It is important that you recognize the algebraic.
Is it too tiny?
No.
In this question, we consider various different transformations of the graph of a function f of x. It is important that you recognize the algebraic form of each function. The given function f of x is a linear function. Its y-intercept is 1, and its gradient is a half. We draw a line through the 2 points. In part A, the transformation has the form f of x minus b, so it is a horizontal translation. b equals minus 2, so we translate every point on the line 2 units to the left. In part B, the transformation has the form f of x plus a, so it is a vertical translation. a equals 2, so we translate every point on the line 2 units upwards. In part C, the transformation has the form c f of x, so it is a vertical stretch. The scale factor c is 2, so we double the distance of every point on the line from the x-axis. The x-intercept is the only point on the line which does not move. In part D, the transformation has the form y equals minus f of x, so it is a reflection in the x-axis. The x-axis is the mirror line, and each point is moved to a corresponding position the same distance from the mirror line, but on the other side of it. The x-intercept is the only point on the line which does not move.
Understand that?
Yep.
Okay, so that's the first one I like to play for us. Second is this.
Previously, we have considered applying a single transformation to a function. This could be a translation, stretch, or reflection. We now consider applying more than one transformation to the same function. We observe how the transformations are related to the algebraic form of the function. The order in which the transformations are performed is important. In part A, we first apply a reflection in the x-axis, so f of x is transformed into minus f of x. Now, recall that for y equals f of x minus b plus a, the graph y equals f of x is translated horizontally b units and vertically a units. In this case, we translate minus f of x 3 units to the right, giving us minus f of x minus 3, and 1 unit down. So we subtract 1. Finally, we stretch the function vertically with scale factor 2. We double the distance of every point on the line from the x-axis, so the whole function is multiplied by 2. The function resulting from this series of transformations is minus 2 f of x minus 3 minus 2. In part B, we are given the function resulting from a series of transformations. We need to describe the transformations that have been applied to f of x in the correct order. We work backwards to undo this function, just like we undo an expression to isolate a variable. First of all,
Can somebody tell us if you're going to walk backward before getting there? This is easy, right? But this is what I need you to think. If you're going to walk backward, do you think it's exactly like this where the last thing you did is to multiply by 2? Or do you think, okay, which is multiplied by 3 in this case? Or do you think after the multiplication had already been done, that's when you subtract 2? Remember. Okay, answer that question first. Let's begin with that. Do you understand my question? Should I say it again?
Say it again.
Okay. You can see 3 is multiplying something and minus 2. Of course, there are internal problems, right? So 3 things happen here. The function was multiplied by 3, which is your vertical translation at some point. The function inside was multiplied by 2, which is your horizontal stretch, vertical stretch, horizontal stretch. Is that not? And there's another one, the translation. What is the vector used for this translation? You might think you know, maybe we don't know. But there's a vector, because something is inside, something is outside. Is that not? So which one do you think was the latest one here? So we can go in that order. Anyone? Yes, sir.
You divide the whole thing by 3 because, as you can see on the one above, you multiply everything by 2.
Do you agree with him? Alex, what do you think?
Should we do about the last thing first, -2?
Why do you say that?
Because 3 is like the entire thing while 2 is out of it. And like there's like order in math that like this is most important, so if we're like tricking to the other side, we should start the least important stuff first and then go towards the center.
Joey, what do you think? Nice try, Alex.
I think I agree with Alex because
So this first?
yeah,
Okay, why do you say
-2
that?
first because the 3 doesn't apply to the -2. I think.
It does.
What is after?
Because you're stretching
Yeah.
everything.
Yeah, because we bracket everything and then
Because
multiply.
you're like when you're stretching a function, you're not just stretching everything except for the y-intercept.
Yeah.
You're stretching everything.
But when you're stretching everything, isn't that what was done here? And everything was multiplied by 2.
Yeah, so everything
Yeah, so
divides
you divide
by
by
3.
2.
But also you need to note, this is not a multiple of 3. Have you considered that?
Yeah,
2 over
it's
3.
2 over 3.
So if you multiply everything by 3, why is this not a multiple of 3?
Because it could be 2 over 3.
It could be 2 over 3. So, let's see. Is it the same regardless of what you apply first? That's a good question to think about, right? I had this debate last year as well.
Notice that f of 2x minus 1 is a horizontal stretch of f of x minus 1 with scale factor 1/2.
Oopsie.
Next we observe the horizontal translation 1 unit to the right.
It's neither the 3 or 2. It's a 2x first.
That horizontal stretch
You didn't give us the
has
option.
nothing to do with everything you've been talking about, because all you had to do is change the variable to a multiple of itself. So that can be easily taken out. Do you understand that? That can be easily taken out. That shows, oh, at some point in your function, you stretch it horizontally by a scale factor of half. That's a compression. So now that this is out, something is easily done. What do you think the next one is when we walk backward? Will it be the vertical or will it be the translation?
And the vertical translation 2 units downwards. So the transformation applied must therefore be a translation through 1 minus 2. Before this translation, we had 3f of x. We observe that 3f of x is a vertical stretch of f of x with scale factor.
Somebody mentioned, I think it was Joey and Alex, mentioned about this. Was it this one? Something about not everything first. I think it was both of you. So if you look at this, let's look at it forward now. If you have a function, you want to do your vertical stretch, you multiply. You want to translate, it does not affect your vertical stretch. Understand? It's going to be something inside, then minus 2 outside. But he has a point. What if it's 3 over 2? Can't we do it the other way around? So that maybe that is 3 over 2. You can try. it should work because there should be no ambiguity in math. Meaning, we could do our translation, but it won't be by the same vector. Do you understand? For you to get your -2 back, it will never be by the same vector. So if you do your translation before you stretch, and you want it to be in the same point, remember, you already, let me see, this is a stretch before you move. Now you move before you stretch. Your movement already has changed the position vertically. So when you are stretching, you cannot be stretching vertically by the same thing anymore. Am I making sense?
Yes.
In this case, you stretch. Maybe after you stretch it vertically, it's here. Then you translate, then you have something like this. But if you translate from here first, and you are here, your stretching stuff will be different. The scale factor will be different, isn't it? So yes, it's right. As long as you can use the right scale factor, you should get the same thing. Do you understand? In this case now, the best thing, the only thing that will be different will be here. Is that not? If you have to change the order. But it's easier to work with integers.
Yeah.
So try to avoid anything, -3/2 or whatever. Work with integers. So try to do something that will focus on the integers. So you can see, again, let's go back to this. It's almost over. I'll play the end one. It's easy to take care of this first, because it doesn't affect anything else. After that is taken care of, take care of your translation. Okay? If you have those multiple stuff.
Chapter 3. So, to map y equals f of x onto y equals 3 f of 2x minus 1 minus 2, we apply a vertical stretch with scale factor 3, then a translation through 1 minus 2, then a horizontal stretch with scale factor 1/2.
Does that make sense? So try some questions on this. Yes, Alison. Okay.
Never mind. I'm organizing my questions.
Oh, okay. When you're done, let me know. So this is an exam. These are practice questions I didn't put, and I would love us to practice. So maybe I come with this tomorrow, especially, so you can practice some of this in the class, and be sure that whenever you have anything like that in the exam condition, you'll be fine. All right. I'm also preparing exam papers at the moment. I found some. I'm still looking at some other resources from other websites. IB style exam for standard level and advanced level and high level, I mean. And I'm seeing some interesting stuff. So that will be the practice for tomorrow for the class. Maybe one of the sessions I will be with the HL, but you guys will just be practicing about this transformation. Okay, so by the end of this week, we're not going back to transformation anymore. Okay? So there are two things here. Again, it has nothing to do with this example yet, because there are so many things to review, different areas of questioning. So the last thing I want is bring everything together and you get confused. Okay, so that's why I'm taking it one step at a time. I'm happy to take everything in one class and go, but it won't help us. So there are two worksheets. One I labeled homework, one I labeled class activity. I'll give you both. Let me see which one is more complicated. So we start with the one with less complication. Okay, this might be less complicated. I don't know. Maybe I just give you both.
Yeah.
You decide with your partner which one you are doing first. All right? Bring it back tomorrow to class if you are not done yet. We continue in class, then we practice the rest as well. So you guys start distributing this. You start distributing this from your end. One is downloaded from the book. One is something I made on the computer, so you will be able to differentiate them. Quickly, please. Just pick and send. Any questions before we close the recording? Turn off our recording. Any questions? No? Alex? All right, so Joey, you can turn this on. Thank you.